Okay. Hello, students. Here I would like to do this lesson. I think finding exact trigonometric ratios without using unit circle. So, so we are most of the students they try to memorize or remember the unit circle. Uh, so if we have a unit circle. So everyone wants to remember, okay, third pi by 6, okay, pi by 3, pi by 2, then 1 pi by 6, 2 pi by 6, then you get 3 pi by 6, which is same as 2 pi by 3. Then it is 5 pi by 6, and 6 pi by 6, which is pi, 7 pi by 6. 8 pi by 6, which can be written as 4 pi by 3. 9 pi by 6, which is 3 pi by 2. 10 pi by 6. So if it is 10 pi by 6, we can still reduce it and say, hey, that's 5 pi by 3. And then finally we have 11 pi by 6. And then we remember, okay, what are the coordinates here? So this is 30 degrees. So cosine 30 by definition. X is here it is. If you see x is cosine and y is sine is by definition. So if I write x, y, it is the x of an angle and the sine of an angle. And we have already seen that cosine of 30 is √3/2 and sine 30 is half. This one is just the opposite, half at 60 degrees. And so on. So we all know this, and then 45 also. Okay, so this is √3/2, and the 45 pi by 4. So this is pi by 4, which is √2/2 and √2/2. So my question is, so much we fill the whole unit circle saying, hey, that's the reflection. This is the reflection over this. And then again you reflect and you figure out all the coordinates for different angles and find a cosine and the sine. But my question is, do we need this? So today's this video I wanted to show that with just by knowing the first three, so just by knowing the 30 degrees, the 45 degrees and the 60 degrees, and the 60. This, if you know these three, we can figure out any exact value of the trigonometric ratio. So how do we do this? Let's take a simple example. I'm going to start with a simple example. Let's say first one. Example number 1. I'll try to do some examples where we don't have to memorize, we don't have to cram, or you can use just a trick or just 2 steps. First step, we need to know whatever the angle that is given, maybe 11 pi by 3, or so we want to know where the terminal side of the angle lies. Is it the first quadrant, second quadrant, third quadrant, or the fourth quadrant? And based on this, based on knowing that the first one is both are positive, this one is minus plus, this is both minus, and we can know what are the signs of the trigonometric ratio. So always remember, this is all are positive here. Here sine is positive, in this case tan is positive, and here cosine is positive, because this is CS. So every time CS, and CS. So using this, we can figure out. Let's take an example, and I'll start with most problems with examples with the radian measure. Let's say cosine of 5 pi by 3. So I've seen you students, you guys, so always try to check on the unit circle that I have right there and say, oh, I want to see where is that 2 pi by 3. I mean, you don't even have to use this. Just think of which quadrant. The first question is it plus or is it minus? That's the first question. How do we know which quadrant? So back of your mind, you have to know that pi by 3. What is pi by 3? Now all this what I'm writing should be done in your mental maths and say, hey, pi by 3 is 60 degrees, 60 degrees, right? So, and then I try to make a kind of also 3 circles here. If you see, how many 30s make up the whole round, which is 360 degrees. And you see in 360 degrees, you say there are 6 on top and there are 6 down. All together they add up to 360. That means there are 12 pi by 6. So 12 30s. If there are, how many 60s are there in a whole around is, you can see 1, 2, 3, 4, 5, 6. So there are 6 60s. 60s basically means pi by 3. So these are the things. And how many 45s are there in a circle? And you can see 1, 2, 3, 4, 5, 6, 7, 8, 45. So that's a 45 degree, sorry. Yeah, 45 degree. Now how do I use this? Let's say, if this question is put, we do know that pi by 3 is 60 degrees. That means you just have to think of, hey, how many, where is this pi by 3? So like how much do you, now remember this should be at the back of your mind saying, hey, semicircle, you know pi by 3, there are 6 of them all around. So that will be half up there, so this will be 3, 1, 2, 3. And then you think, okay, 1 pi by 2, 1 pi by 3, 2 pi by 3, 3 pi by 3, then 4 pi by 3, and 5 pi by 3. So because all around is 6, right? So that means there's one less, so you have to go back here. So that's how you decide and say, hey, that angle is, so I'm going to put an arrow to show that this angle, 5 pi by 3, 5 pi by 3, which is, okay, you can think that 5 times 30, which is, and this is the easy, you get confused with the radian thing, you can just multiply 5 to 30, 60, and you get 300. And you can clearly see 300 is already, this is 180 landmark, this is 90 mark, this is 270 mark, and this is 360, and 300 is between 270, and so it lies in the, so basically the angle go this way, right? So that's 5 pi by 3. So the moment you know that, we know which, but is it positive or negative? We know this first one is positive and negative, this is x and y, that's cosine and that's sine. That's it. So that means this cosine has to be positive. So this, how many pi by 3 decide the terminal side? This is the terminal side of the angle. Let's see, this is the, if this was the original initial side, so it rotates around the origin and lands in the fourth quadrant, right? So 60. So we can do. And now you just take off this 5. So no more 5 because that's the. So this angle becomes the reference angle. Now here we don't even have to do pi minus and all that. We can just know that, hey, that's 60. That's pi by 3. So we say, hey, the angle is cosine pi by 3. And cosine pi by 3 is cosine 60, which is half, and you're done. So basically you are doing most of the work mentally and say, hey, all this you are thinking which quadrant it goes. So we'll take one more example this way and see what's going on. Second problem, let's take a sine, and this time it's the sine of 7 pi by 6. If you can remember, good, but what about sometimes, like, there's not enough time when you go to, let's see, if you want to figure out what is sine of 19, let's take example, 19 pi by 12, and this one has a 12 and doesn't have 6 or 4 or 3, so we need to do that. Maybe we want to write it as 10 plus 9, 10 pi plus 9 pi, and then divide this way. And then we end up getting the same thing, and it should be just like that, do quickly, because you're going to use compound identities, later compound identities where C of A plus B is C of A cosine cos, and this minus sine of A and sine of B, and there are 4 of them, so that's what we are getting ready for. If this was the question, what is the first thing you're going to do is, hey, is it plus or is it minus? Where is this quadrant? 7 pi by 6. Back in your mind, you're thinking, you have to, this is all in your mind, right? And if we go up here, there are 1, 2, 3, 4, 5, 6 30s. What is pi by 6 basically means? So pi by 6 is 30 degrees. So that should be by default. We have to know that. And then 7 times. So until this part is 6 of them, and then you go another one. So that's so simple. So you're doing in a mental math and say this is in the second quadrant. How do you know this is in the second quadrant? Is because 6 pi by 6 is semicircle, but because it is 7, there's one additional. So sorry, this becomes the third quadrant. So that's why in the third quadrant. So let's go back right here. So the angle is the third quadrant, see. So in the third quadrant, it's all sine. You can remember we have seen that this is add sugar to coffee. So you can remember this way also. Like here everything is positive. Here only sine is positive, right? And this one is tan is positive. And this one cosine is positive. So that way we know which one is negative. So if sine is positive, of course if sine is positive, cosecant is also positive because the definition is reciprocal of sine. So sine and cosecant takes the same value. And the same thing here, secant and, so let me take this off, just too much of stuff here. So here, secant also will be positive. If I say tan is positive, then cot is positive. Okay, so let's see, get back. So this is the third quadrant, and third quadrant, tan is positive. So that means by default, the rest of them sine, cosine, and cosecant, and secant, this will be negative. So the one that gave us is sine, so this is minus sign. And then you delete this side and just write down the reference angle, which is pi by 6. So all this is done mental math, and so that means the angle is, see this one, it is in the third quadrant. So this becomes the reference angle, which is pi by 6, because until here there are 6 of them. You can clearly see over there 6, and then another one. So 7 pi by 2. So the answer is, and the final answer is minus, and this is sine 30, and sine 30 is half. And you're done. So this is how we can avoid the unit circle. The goal of this my video is, hey, can we do mathematics without using unit circle? Or can we figure out the trigonometric ratios without looking at the unit circle? Let's take a few more and get it down, and also take some in degrees. So the one that I'm showing is in, so the one that I'm showing is in radians. Let's take something in tan. So tan of 11 pi by 4. Okay, so tan 11 pi by 4. Where is the angle? Now the main angle that you see is pi by 4, right? So how many pi by 4 make a whole around? And you can see 8 of them, right? And then you can say, okay, it's 11, so you go all around, which is 8, and then you go 9, 10, and 11. So all that you are doing in your mind and mentally you're figuring out which quadrant this angle lies. So this is, let's write it. So this angle, this part is, or you can think, okay, let's multiply 11 to 45. That becomes a big number. Look at this. So instead of this, better to remember 1145 basically means you're going around and say, hey, all around here is 8 pi by 4. So till here is 8 pi by 4. And then you don't know half of them is 4 of them here. So because it is 11, so I go 8, 9, 10, and 11. There I go. And this is how the angle goes in the this is in the second quadrant, right? So in the second quadrant, it's minus and plus. This is how you should remember. What does that mean is, if it is minus and plus, it means first one is x, y. By definition, this is cosine, this is sine. And what is asked is tan. But what is tan means? Tan is y over x. So that means you just have to, it's like plus, divide by minus, which is minus. Or you can directly remember over here, sine is positive, cosecant is positive. So the rest for trigonometric ratios are negative. So this answer will be negative. You can clearly see why and how. If you get confused, that's how you do show. And the answer is minus tan of pi by 4, and which is minus tan 45, and tan 45 is 1, and done. So let me go quickly and show with the negatives, let's say. Let me wipe this off. So we will take one example with negative radian, and then another 2 or 3 maybe in degrees. So it's the same thing. If it is degrees, sometimes become a little one step you may be needing, like to figure out the reference angle. Let's say if it is, they give you 250, let's say they give you 240. So then what is 240? So we need to figure out what is the reference angle. So first of all, 240. Where does 240? Let's take that an example and do that. So let's take a cosecant. Let me take cosecant of, let's say, minus. I want to take one example of maybe 6, 10, 11 pi by 6. Let's do this. What is this answer? Okay, first step. Where are we? Which quadrant are we talking about? So it's negative, right? So you need to go, this is clockwise direction. So if it is clockwise direction, where are we? So you are going around clockwise. That means there are 11 pi by 6. All around is how much? 12 pi by 6. So look at this. There are 12 of them. But here it is 11. So you go all around. So half will be 6 pi by 6. And then you go this one. If you go touch here, that will be 12 pi by 6. The 12 30s give all around, so it will be one less. It becomes this. So that's the angle, this one. So which quadrant are you on? In the first quadrant. Now in the first quadrant, everything is positive. So the answer for this will be positive cosecant of, drop the 11 and just write pi by 6. And now, by definition, we need to know what is cos. To figure out what is cosecant, we need to know what is sine of pi by 6. Because you know pi by 6, and cosecant is the reciprocal. Okay, by definition, cosecant here. So if x is sine x, sorry, y is sine x. So cosecant, the definition is 1 over y. But y is sine x. So if you know, if we do know what is sine, the cosecant is just a flip of it. So this is sine of 30 degrees, which will be 2.5, and then you just write the flip of it is 2 over 1, and you're done. So this is how we can figure out that one. So one more thing is, let's take now another example of, one example of in degrees. So the example, I'll just take in random, let's say it is 210, or let me write cotangent of 225. 225. Okay. So 225. Where is this angle? First of all, where is this angle? By just looking at the landmarks, you know this is 270 and that's 360. Now because the angle is given in 90 in degrees, So 225 degrees will be somewhere here, right? Somewhere here. Okay, we don't know where exactly, but at least you know it is in the third quadrant. It's both negative x1, and remember here tan is positive. If tan is positive, means chord also is going to be positive. So what do? We write this here first of all, because it is in the third quadrant. You put plus, and then we need to know what is the. So this is where the problem lies. Reference angle. We have to know what is the reference angle. So last video I focused on how do we find reference angle. It's the acute angle made by the terminal side. This is the terminal side. So this is 225. Let's see, this is 225, right? So if this is 225, the reference angle is this one, right? And by default, you should be knowing the formulas that just a quick you clearly see here that if the angle is in the third quadrant, what you do is theta minus 180. So you want to know this is 180. So you want to know, you do need to know how much more is 180. So that theta, whatever the angle, you subtract 180, and that's how we can figure out. So here theta is theta, so the reference angle is, so we need to write this cotangent of the reference, this because is the reference angle. So theta minus 180, right? So in this example, it is 225, and you already know the answer, which is 45 degrees, right? So this thing turns out to plus 45. And what is tan? Now you don't know what is tan 45. So if you do not know what is tan cotangent, at least we do know from by default that this is 1. So the tangent, if tangent is 1, then the cotangent is also 1 over 1, which is 1, and you're done. So this is going to be plus 1. So simple. Let's take another last two more. And this time, let me pick a little larger angle. Let's say so secant. Let's take a secant of secant of minus 720. 50, let's say. So I'm playing with these numbers, right? So first of all, 720. So the angle, if you see, it rotates. So this is the initial side. It is. If you have an initial side this way, then what is 720? What is like how many around? Like, and you can say this one is the terminal side. It goes once it goes around, that's like 360, one 360, right? And then it goes another 360 because 360 is 720. So you have 360s, then you have another 360, so 2 times. So that means, first of all, you need to little kind of a work here. You can say, hey, 2 times 360s is 720, right? So that means 750 is how much more? So 750, if you take away 720, so that becomes like 30 degrees. So that means if I want to know what is this 720, so that means this one is, you go 2 rounds. So that means you go 1, 360, 1 more 360, and then you go a little beyond that. So how much extra is 30? So this is 720 degrees, but the reference angle, this part, is 30 degrees. So simple, okay? So this is how you do. Then, because we are now, the terminal side lies in the 4th quadrant, first one is positive minus, and this is how I like to see that x and y, that means cosine and sine. The question is secant, right? Now to know secant, at least we should know cosine. So what is cosine? Cosine is positive, see? So that's why this answer is going to be plus. And this is written as reduced, that gets reduced to this value for this minus 720, the all around minus 720, and secant of 30 degrees is the same thing. Okay. So you just use the reference angle. This plus sign takes care of those many rotations. And then what is cosine of 30? And cosine of 30 is 2 by square root of 3. So if that is the case, then secant is reciprocal of this, which is plus square root of 3 over 2. So cosine, I made a slight mistake here, I'm so sorry. Cosine 30 is root 3 over 2. So this will change to 2 over square root of 3. And you cannot have a radical in the denominator, so just multiply this. So the numerator will be, and this 2 radical square root of 3, that will give this way, and you're done. That's how it is. So as I said, this video I'm making made only to without using the unit circle, we can figure out any angle. Of course, if it is like pi by 8, we can't do that because we don't know the actual values. So the only this works is only when it is 30, 60, 45 degrees. Let me try one more time if I still have time. Please, I did take cosecant, secant, and let me, can we do directly, let's see, cosecant, let's take one more. Cosecant, minus 17 pi by 3. Let's check this. How do we do this now? So if I want to figure out 7, now again it's a rotating around, right? So now no more, I'm not going to do more calculation, I just want direct answer now. So no more writing the work. Hey, pi by 3. So how many pi by 3s? So you can see the all around. So all around is 6, you can say that 6. So you go 6 pi by 6, see that? So you go 6 pi by 6, and then I can go another 12 pi by 6. And then there is a 12, 13, 14, 15, 16, 17. So there are 5 more. So I can go semicircle and say until here there are 3. So 1 round 6 plus 6, 12 plus 3, 13, 14, 15. And then I need to have 2 more because 17, right? Because the all around till here will be 18, right? So there are here, until here there are 3 more to get 18. So that means there are 1 here and a 1 here. So we want 2 more. So you go, okay, that's 16, and then here and this. And then hey, everything is positive here. So this is plus, and this is drop the 17, and it is a sine of 60. What is sine 60? Sine 60 is root 3 over 2. So cosecant is becomes 2 over root 3, and do the same thing and you get the answer. So simple. And maybe last one, I'm always saying last one. Because just for a practice is always better. And let's take cotangent of, I took pi by 3 or 15 pi by 4. I don't know whether I took this, or let's see like a, let me take it 360 plus, okay. I'm just making my own 585. So suppose it is 585. So what is cotangent of 585? So remember, this is more than 360, so you can just subtract 360, because that gives you a coterminal angle. So you get 225. So cotangent of 225, and you know what is cotangent of 225. 180 plus something, right? So same thing, and you want to know, so that will be 225. So the answer is this is both are negative. So sine cosine are negative. So tan is positive and cotangent also is positive. So it has to be plus because of that. And the semi reference angle will be 225, and this is 180 mark. So just take away 180 and you get 45. And so this is like cotangent of 45, which is 1, because tan 45 is 1. So because tan 45 is 1, so all these examples I'm doing, you can just practice more and more. We will see in the class when you come on on Wednesday, that the more practice you do on this, it becomes so easy. And do not be dependent on that unit circle, which everybody has become crazy. Oh, you need to have a unit circle during the testing. But what do you do when you go to the AP calculus class and higher classes, so calculus B, C? This should be, and especially when you are working with the polar equations, from changing from rectangular to the, so we need to know that, hey, just like that, how much, where is this angle and what is the answer. So hope this video will help you. Okay, thank you so much. As I said, I'm making these videos for my students so that they can go back. Sometimes in the classroom they don't understand, so at least you watch the video and say, hey, now I know why it is this, why is that, how to figure out. You can go back and just play it again one more time. That's the goal, and especially students who are missing and maybe are struggling. So bye, take care.